Hello, and welcome to our program, Astronomy for Everyone. The topic for this month's show is interstellar objects. And here to inform us about this interesting topic from the Warren Astronomical Society, Jonathan Kade. Jonathan, welcome back to the show. It's been a while.
It has been. I've been pursuing many interesting different topics like interstellar objects. And I have a selection of them to share with you today. In fact, pretty much all the ones that we know about.
Well, great. Well, can you tell our audience just a little bit about how you got interested in astronomy?
Yeah, so when I was a child, I got really interested in the book learning side of astronomy, but it took actually getting into a committed romantic relationship with frequent Astronomy for Everyone guest Diane Hall to get me to actually start practicing astronomy and using a telescope. So she and I are long-term observing partners and have frequently been pressed into service on the board of the Warren Astronomical Society.
Yes, you have, repeatedly over the years. So,
And are again.
lucky you. So let's start with a tour of the solar system.
For sure. So, everyone thinks about the sun and Mercury and Venus and the Earth. And at the distances that we're talking about, we've just omitted Venus and Mercury from the diagram here. But where things start to get interesting is the orbit of Neptune, which is 30 astronomical units. That's 30 times further than the orbit of Earth from the sun. And beyond Neptune's orbit, we encounter this system called the Kuiper Belt. And that's in the same, like the solar system is as flat as a pancake. And the Kuiper Belt is this ring around sort of the outside of that inner solar system guided by Neptune. And so you could say that the Kuiper Belt is getting to the edge of the sun's sort of ordered solar system.
Okay.
And beyond that, you have all of these, basically comets sitting there in this belt around the edge of the solar system. And beyond that, you have sort of the shell of the sun's atmosphere, and that it's a sheath of the gas being blown off the sun every day. And where you get to the edge of that, so that's called the heliosheath. The edge of that is called the heliopause, where the sun's exhalations stop and you start to get into the interstellar medium. And so that's sort of the first definition of interstellar. So we're outside of the sun's, you could say the solar system itself ending at the Kuiper Belt is one definition of interstellar for our solar system. You could say that the heliosheath and heliopause is the next definition. And then beyond that, you get to this further system called the Oort cloud. So everything in the inner solar system is flat as a pancake, but the Oort cloud is this giant circular cloud, spherical cloud around the entire system. So comets that are in the Oort cloud don't just orbit in the plane of the solar system, but they orbit in a 360-degree shell around the sun.
Oh, I see.
And so that is the physical, that is the limit of the sun's real gravitational influence. That's where everything that is part of the sun and is moving with the sun through our galaxy is in that outer shell of the Oort cloud. So that's the furthest definition of in non-interstellar. So anything past the Oort cloud is 100% interstellar by any definition. But each of these definitions is interesting. So we may have made our own interstellar objects.
I was going to ask about that. As I recall, over the decades, we've done that.
Yeah. So the Voyager spacecraft, the first one, Voyager 2, actually was further out. So Voyager 2 went into interstellar space by definition to outside the sun's atmosphere in 2012, and Voyager 1 followed in 2018. And so they are on a, they are free of the sun's gravity. They're outside the escape velocity of the solar system. And so over time, they are going to become interstellar objects are going to get past the Oort cloud, assuming they don't hit a comet out there, but the distances between comets is so vast that it's very unlikely that they're actually going to hit anything. So the odds are very good that we're going to have two spacecraft exiting the solar system. Beyond that, we have Pioneers, we have New Horizons. They're all on a, like New Horizons is going to exit the heliopause in 2070 or so. And beyond that, they're all eventually going to leave the Oort cloud and be in true interstellar space. That's going to take 30,000 years. So.
Okay, so we won't hold our breath for that.
So don't wait for that to happen.
Okay, all right, so those are the man-made interstellar objects. Now, there are those interstellar objects that are not of this Earth.
Yeah, so 10
Or
years...
even the solar system, for that matter.
Yep, yeah, exactly. So 10 years ago, I would have told you that there are no known interstellar objects at the scale of a comet or an asteroid or even a planet that we've observed. But in 2017, we discovered this strange object that came to be called Oumuamua. And it's a really strange object. We couldn't figure out, looking at it, what is the shape? Is it a cigar shape? Is it a pancake shape? And we also couldn't figure out what it was.
Also, the name is derived from Hawaiian.
Yeah, so Oumuamua is a Hawaiian, kind of an invented Hawaiian word put together that means like the earliest distant voyager, because it's the first interstellar object that has come to us.
Okay.
And so when they first discovered Oumuamua, they didn't know what kind of category to put it in. Is it a comet? I mean, it might have been a comet, but is it... So they ended up inventing a new classification of objects. So Oumuamua was retroactively named One-Eye Oumuamua, and the one eye is interstellar. So it's the first interstellar object. And so the observations that the professional telescopes, both on Earth and in space, took showed that it was extremely red, and it showed a light curve that actually meant that the comet, or I don't want to say comet, the object was tumbling in some kind of strange way that meant that, when the long side or the flat side was facing us, it would be very bright, and then it would turn in such a way that it became very thin. And this led people to come up with all kinds of interesting hypotheses about what exactly shape this object was and what its nature was.
Okay, it led some people, I think, to believe it was an alien spaceship.
Yeah, there's one prominent researcher at Harvard University that we'll talk about a little bit later, who has so far, I think, said all of the known interstellar objects might be spaceships. Maybe not the second one. But what is true is that we, even now, after all the observations we've taken, we don't know what it is. Is it a comet? Is it an asteroid? Is it some previously undiscovered thing called a dark comet? Like we saw it was super red. None of the comets that we see in our solar system are super red like that. They're very obviously covered in ice. If this is covered in ice, it has a shell of some kind of other substance over the ice. And that's pretty rare. But it could have been some kind of primordial leftover that we've never seen. Like maybe it's the kind of thing that gets made in a red dwarf system that we don't see in our solar system. Or maybe it was even a chunk of another planet that got broken up and blasted into space. We have an artist's rendition on the slide here of one possible process by which that might happen. Probably not super likely. And of course,
that
there's
looks like the Death Star.
that is in fact the Death Star. Okay. So it could have been a chunk of Alderaan. I don't know. But and then because it was such a weird shape, it could have been this long cylinder. It made people think of the old Arthur C. Clarke novel, Rendezvous with Rama, which featured this tumbling space station that was, very similar physical characteristics to this. So that's what got people thinking, oh, it could be a spaceship. But we never saw any activity on it. All of the, it was completely dead. We saw that the chemical composition of it that we could analyze was just rock and possibly ice. And there were no signals or anything else. So we don't have any reason to believe that it was anything other than an inert chunk of rock or ice.
Okay, so Oumuamua is the first interstellar object. What's the second one?
Yeah, so, and just before we move on, Oumuamua is coming from, above us in the galaxy and heading below us.
Oh, okay, yeah.
And it got slingshotted by the sun. It was coming down, and the sun slingshot it up from our perspective, from our usual. Obviously there's no up in space, but and so you'll see with some of these other objects that they followed very different trajectories. So that second one is called Comet Borisov, and a Ukrainian. Actually, I guess we shouldn't get to that first, but Borisov, there's no question about what the object is. And so if we look on the slide, if you look at the picture of Borisov on the slide, it is a comet. There's, looking at it, it looks just like the comets that we see at home. And in fact, the chemical composition, very similar to the comets that form in the solar system. The only reason that we know for sure that it is an interstellar comet is that there's no way it could be moving through the solar system with the kind of speed and at the kind of angle it had if it was formed inside the solar system. No combination of the gravity of Neptune and Jupiter could do that.
Oh, okay, so from that we can safely assume it's coming from elsewhere.
Yep.
And so that was the second one. As you say, you mentioned it was a Ukrainian.
Yeah, so a Ukrainian professional astronomer named Gennady Borisov, who observed in Crimea, and unfortunately that's now under Russian occupation. But he has built a collection of his own telescopes, and so he was able to observe that comet with his own hand-built telescope, which is really neat. Instead of these other objects are all discovered by professional sky surveys, and so for somebody to discover it with a piece of equipment that he himself built is a really unique
An
thing.
Amateur like us. But.
I mean, he's a professional, he's an amateur astronomer, but a professional astronomy technician, I guess. So he works for a university astronomy program maintaining telescopes. Yeah.
Interesting. Well, Jonathan, we're going to take a quick break right here. If you have a question, please send us an email. And coming up next is Term of the Month with Stephen.
Thanks, Don. The term of the month is Type 2P supernova. Results were recently published for an observing campaign for Supernova 2024 ABFI. This is a low-luminosity Type 2P supernova. There are two classification groups of supernovae. Type 1 have no hydrogen in their spectra, and Type 2 have hydrogen. Type 2L, L for linear, get bright, then have a fairly rapid linear decay light curve. Type 2P, P for plateau, get bright and then remain bright on a plateau for an extended period, usually lasting about 100 days. Supernova 2024 ABFI is the 8,393rd supernova in the year 2024, and it happened on November 15th. It was magnitude 17.5, which is pretty dim. The host galaxy is NGC 2164. Observations show it as a low-luminosity supernova Type 2P. Archival Hubble Space Telescope data have identified a possible progenitor with an initial mass of 9 to 12 solar masses, a low-mass red supergiant nearly 1,000 solar radii, nearly the size of Jupiter's orbit. In the supernova event, 8.3 solar masses was ejected. Ejecta speeds were lower than normal for Type 2P supernovae. The slower speeds may explain the long brightness plateau. About 37 days after the explosion, a hydrogen alpha absorption appears, perhaps from a plume of inner ejecta moving faster. Then 24 days after that, emission features show up at speeds of around 2,000 kilometers per second, perhaps from circumstellar medium interaction. The nebular phase starts at around 138 days after the explosion. And that is the term of the month, Type 2P supernova. Back to you, Don.
Thanks, Stephen. We're back with our guest, Jonathan Kade from the Warren Astronomical Society, and we're continuing our discussion about interstellar objects. So, Jonathan, what's the story with the third interstellar?
So Comet Atlas is the most recent of the interstellar objects that we have seen well, and it actually came to visit us last summer, and I tried very hard to see it in December, but it was a little bit too faint for the skies and the equipment that I had. But a lot of, not a lot of amateur astronomers saw it visually, but a lot of them imaged it. And again, like Comet Borisov, there's no question about what it is. It's just a comet. But it is a lot more interesting than Comet Borisov in certain ways.
Okay, so interesting is like, what's so weird about it?
Yeah, so basically where Comet Borisov was very similar to the comets that we see in our solar system, what's weird about Comet Atlas, I think we got the wrong slide, but what's weird about Comet Atlas is that it is a different chemical composition. It has much less carbon compounds than has ever been seen. And it also has much more carbon dioxide than is normal for comets that we see. But unlike the other two comets, it shot through our solar system like a bullet. So if we look at the slide showing its path through the solar system, it came in from one side of the solar system and ripped right through and went straight across, and the sun barely moved it.
I was just going to say, did it have the same effect as the first one?
Yeah, the other two, as you might have seen in that animation earlier, they got whipped all the way out of the solar system. This one kind of went straight through. It also didn't go as close to the sun as the other two did. But what's interesting about this one is it's actually moving parallel to the sun in our Milky Way. So it actually is following a similar course around the Milky Way. Because it had such a straight orbit, and because the sun didn't change it as much, and because we have so much more telescopes in operation, both in space and on Earth, we got much better data about its orbit. So we can actually figure out how it's going to move in the Milky Way, and what we see is that it's a very similar track around the Milky Way to the sun. And so it's kind of interesting. Another interesting thing about it was that it came from the bottom of the Milky Way and went up through the top. For various reasons that I won't go into, astronomers think that it's more common for there to be, for stuff to be coming from above us in the Milky Way because of where we are. And so they were surprised to see that the third one was coming from the opposite direction that they expected.
Okay, so I guess the big question is, do they ever come to Earth?
So, the odds are, since we've had all these telescopes out there looking, we have had 3 already, right? Just in the last 10 years. And so the odds are very good that more of them are coming to Earth. Some people have even hypothesized that maybe, the dinosaur killer could have been an interstellar comet. We don't have any good evidence to support that, but, it's a fun thing to think about.
So is the whole thing that we just have better tools to work with to find these?
Yeah, we have many more space telescopes, and the telescopes that we have on Earth, we have a lot more sky survey telescopes, like the Vera Rubin telescope. And so as a result, I think we're going to be seeing a lot more of these objects discovered. It's similar to exoplanets, right? When we first found the first exoplanet, we were blown away that we could discover even one of them. And then we found 16, and then we found 75, and now we're at 13,000. So I think a similar process is going to happen with interstellar comets. And professional astronomers, like in the paper that we're showing, also believe that to be the case. They think that the more that we see, the more time goes on, and the better we get at detecting them, the more we're going to see and the more we're going to learn about them.
Are these being discovered in visible light using the telescopes, or is it some ultraviolet, infrared, or radio?
So for the most part, all three of the ones that we've discovered so far have been discovered in visible light.
Okay.
So now we use other wavelengths to see interesting things about them, to do chemical analysis, to do spectroscopy, to see how cold or hot they are in infrared. But at this point, so far they've all been discovered in visible light. That could shift over time, though.
Wouldn't surprise me. So what about the comet interceptor?
Yeah, so the dream of astronomers is to be able to go up close to one of these objects and look at it closely. Oumuamua is the one that we really wish we could have seen, because we still have no idea what it really is. But the European Space Agency and the Japanese Agency for Space Exploration, JAXA, have put together this probe called Comet Interceptor. It's actually a 3-probe system, and the plan is to launch it by the end of 2028. It might slip into 2029. And these are going to go park out in a distant orbit and wait for an interstellar object to come, and then they are going to have fuel on board so that they can go chase it and catch up with it and see it up close. And hopefully, in our lifetimes, we may get to see that.
That would be interesting, to be able to have the opportunity to chase one of these and get up close and personal, kind of like some of the missions that we've sent to, like Bennu.
Yep.
Retrieving samples and coming back. I don't know that these would
Yeah.
gather samples, but hopefully they would get close enough to be able to learn things that we can't from the distance that we've had to look so far.
Yeah, I believe what has been built can't do sample returns, but they are going to do spectroscopy up close and get much better images.
Well, yeah.
And then in the future, obviously, there are a bunch of proposals for missions to do sample returns and to, do various. In fact, there's even proposals to catch up with Oumuamua that involve getting these Janus probes that NASA built and then put into mothballs, getting them out of mothballs, putting them on a fast rocket, and they think they could catch up with it by 2036.
Really?
I don't know if they're right, but there's a proposal out there to do it. It's not funded, though.
Okay, well, that would be a U.S.
Yes.
mission
Yeah.
if they
Yeah.
found the funding for it.
Yeah.
Of course, the funding is part of the problem, like the sample
That
return
is
from Mars.
that is a big part of
Yeah,
most problems. Yep.
So do any of the other space agencies, you mentioned ESL and JAXA, Chinese?
Not that I'm aware of, but there's going to be a lot of prestige involved in getting more information about interstellar objects. So I would expect everybody who has the capability to do so is going to be trying to do it. Now, there are even private attempts to get both comet interceptor probes and also build interstellar probes of our own that are intended to do nothing but go interstellar. So Johns Hopkins University has a solar sail that they want to build that is going to go interstellar if it gets funded.
Yeah, the funding is the important key.
Yep. But they're looking for private funding for that, so it's possible that maybe various governmental funding woes may not affect them as much.
Well, I'm thinking, too, with the better tools, as we discussed just a moment ago, we'll be able to spot them sooner.
For sure.
And be able to key in on them to get a good look.
Yep. We're pushing back. So far, all the ones that we've found have been inside the orbit of Jupiter. If we can find them at the orbit of Saturn or the orbit of Uranus, it's going to mean that we have a lot more time to prepare.
Okay. So it sounds that there's a lot of interesting work ahead that can be done.
Yep. And, one thing that we didn't get to talk about as much is that, in terms of them coming to us. There have been some interstellar meteors, claimed interstellar meteors. So basically the Space Force and the Air Force saw these blasts happen in Earth's atmosphere from meteors blowing up, and they decided to publicly declassify these and release them.
Okay.
And the aforementioned astronomer at Harvard, Avi Loeb, has actually written proposals to try to retrieve them. They actually they caused a minor diplomatic incident off Papua New Guinea, trawling the ocean floor in what turned out to be Papua New Guinea territorial waters, looking for chunks of this potential interstellar meteorite. And unfortunately, what they've found hasn't convinced anybody that they found it.
Okay.
But you never know. Maybe we will see a meteor that we can find and can prove chemically that it came from a different system.
Well, it'll be interesting to find out. I want to thank our guest, Jonathan Kade from the Warren Astronomical Society, for being on this show this month to fill us in on the interesting topic of interstellar objects. Please visit our club website. The address is down there, as always, at the bottom of your screen. And coming up next with What's Up in the Night Sky is Stephen.
Thanks, Don. What's up in the night sky for March 2026? The sun goes from Aquarius to Pisces with Saturn, Mercury, Venus, and Mars close by. Spring equinox is March 20th. Daylight savings time is on the 8th. That's spring forward in the northern hemisphere. Is that fall forward in the southern hemisphere? We feel your pain. Then we have the moons. March starts with a full moon on the 3rd, third quarter on the 11th, new moon on the 18th, and first quarter on the 25th. Then we have a bunch of planets: Mercury, Venus, Neptune, Saturn, Uranus, and Jupiter, shown on the 1st of March at sunrise, a little bit before sunrise. Mercury goes from Pisces to Aquarius, which is opposite what the sun does, and it sets at half an hour after sunset to rising an hour before sunrise. It has inferior conjunction on the 7th to make that happen. Venus goes from Aquarius to Aries and sets an hour after sunset to half an hour after sunset. Neptune is in Pisces and rises an hour and a half after sunset to basically sunrise. And that's because it has superior conjunction late in the month on March 22nd. Saturn does much the same thing in Pisces, sets an hour and a half after sunset to sunrise. It has superior conjunction on the 25th. Uranus is in Taurus and sets from 5 hours to 4 hours after sunset. And then Jupiter is in Gemini and sets 2.5 hours before sunrise to 3.5 hours before sunrise. And then finally we have Mars, also shown on the 1st, but in the morning basically at sunrise. Mars is in Aquarius and rises from sunrise, as shown here, it's in the glare, to half an hour before sunrise. And so it's actually better at the end of the month. It's a little farther away. And that is what's up in the night sky for March 2026. Remember, we don't charge money for this show, but we may tax your brain.